Hey, so I'm putting together a recording for you guys to use for the Unit 2 lab. So you do want your laboratory guide. You should have got one of these with your kit. If you didn't, I'm going to show you where to find a version of this in the course online. And then we'll talk materials and things. So let me share my desktop here. And all right, so let me go back to the home page. So you can kind of start from the beginning here, but here's class homepage. If you go to this first area in the class content bar called course materials, you'll launch that and then scroll down to chemistry laboratory guide. When you click on that one, there's a couple of links. The top link is a more basic version of the book. That's good if you have a slower internet connection. The second one is a little bit fancier, but it uses more bandwidth, so you need a better internet connection for that one, but they both have the same information. All right. I also have here, my workspace. Right. For this lab, you definitely need to wear some safety equipment. All right. So I've got some plastic gloves. All right. You'll want to wear those because we are going to be working with sodium hydroxide, which is a very strong base. And if you get it on your skin, you want to wash it off right away. And you want to protect your eyes from it, because if you get it in your eyes, again, you need to wash it off right away, but it could cause damage to them. Your eyes are precious. You don't want to lose sight because you decided to be careless with a chemistry experiment. Okay. Some other materials that you're going to need is, we've got a mortar and pestle. So for those of you that actually have chalk at home, you'll use this to crush up the chalk. If you don't have chalk at home, I'm going to demo chalk right here, so that's okay. You're going to need some pipettes again, like from the Unit 1 lab. I actually am reusing the vinegar oil and water one, and then I made a new one labeled VIN for vinegar. You'll need this metal scoopula. It's going to help you get the solids into the well plates. And then the stirring rod from your kit. You've got a few of these. You can use this in place of the toothpicks. Okay, so if you don't want to go out and buy toothpicks, you can just use the stirring rod. The big thing is you got to remember to rinse it off after every trial so that you don't contaminate your samples. Okay, so you don't want to work by sink or have a beaker with some extra water in it, something like that, so that you can clean it off after each time you use it. Some other stuff out of your kit, you'll need a well plate. And there are 3 chemicals, which in the class presentation, I gave you a nice big zoom up of these because I don't think I'm going to get a good enough view on here. There we go. That kind of says potassium chloride. So there's that bottle. The sodium hydroxide bottle looks like this. All right, so I know the lab manual says it should be 0.1 M, but this bottle actually does say 0.1 N. Same thing. And citric acid, 3.0 molar. I think at some point there it kind of got not blurry. Okay. From around the house, you're going to need a few other materials. You're going to need granulated sugar, salt, table salt, vegetable oil, water. You know, if you have distilled water, great. If you don't, that's okay. Sugar and baking soda. All right, so those are going to be some of the other things that we do. The chalk is technically also something to be around the house, but I'm going to do that for you just in case you don't have that, because it's not something I would expect to be in your pantry. So let me put on my safety equipment. I apologize for those of you that have bigger hands, because it seems like they send out the smallest gloves possible, which are even kind of tight for me. And let's see, just to prove it, I am wearing my goggles. So I'll go back to screen sharing. All right, so everyone, minimize that. All right, so the instructions for your lab are on page, they start on, let's see, the lab starts on page 6, the instructions start on page 7. And actually, I want to focus you in on something on page 8. Okay, so in this lab, in the wells, you're going to be combining 2 chemicals. Let's see, that is not visible whatsoever. Let me bring that up a little higher. All right, you're going to be combining 2 chemicals in this exact pattern. All right, you notice there are 24 empty squares. There are also 24 wells in your well plate. All right, so what you're going to put in the very top left well is chalk and distilled water. What you're going to put in the well next to that is salt and distilled water, and then the potassium chloride and distilled water, and then baking soda and distilled water. So this is showing you exactly how you need to combine things. All right, so you'll put chalk in all 4 of these, and then you'll put these liquids mixed with the chalk. Okay, so this is, you know, this isn't a horribly difficult lab. You just need to make sure you mix all of these. Let's see. One other note in the observation, in the procedure that I want to make is a change in step number 2. And actually, I'm going to write this in here. Okay, so just to make note of this one, what I have found in this lab that the amount of the solid that they tell you to put in is way too much to make it easy for you to spot if there's a, you know, to tell dissolving apart from mixing. All right, so in here it says approximately 1/4 of the way with the chalk. Honestly, use as little solid as possible. Just a small, you know, pinch of it in the bottom of the well. And I'll show you what I mean by this when I demo the chalk. Okay, so getting into the demoing of the chalk. Or I guess just to kind of explain that one, why you want to use so little solid, is these wells are pretty tiny. All right, you can't get much liquid in there. And dissolving is related to the solubility of a liquid, and that is dependent on the amount of liquid you have. All right, water can't dissolve salt forever. Eventually, you max out the amount of salt that the water can dissolve. When that happens, you end up having salt left behind. All right, so if you put too much solid in here, you'll end up having a hard time spotting dissolving. All right, so I'm going to change that procedure just a little bit so that you don't run into that issue. So we're going to do the first column of your lab, which is the chalk. All right, and I have actually taken the liberty of already grinding up my chalk. Right, to use the mortar and pestle, you just kind of take it and move it around in here like a circle until it crushes the chalk. Initially, you might have to do a little bit of like twisting and grinding to get it broken into smaller pieces. If you're doing the chalk yourself, for those of you that are just watching this to get it done, you don't even have to worry about it. So I'm gonna put down a towel here. All right, so chalk. So that very first well plate was going to be chalk and distilled water. What I'm going to do, just to save myself a little bit of time, I'm going to get all the chalk in the well plates now. So I apologize if the sound is really horrible. See if I can, but that's the amount of chalk I'm thinking is going to be plenty, right? It's just barely covering the tip of that scupula, all right? And when you see it, it doesn't even cover the full bottom of the well plate, all right? That's the most you want to use. Don't use more than this. When it comes to putting the solids into the wells, less is better, all right? Now, do be very, very, very careful that this chalk only gets into these first 4 wells and not into any of the other ones. If you make a mistake and you accidentally get a little bit in something else, what I would suggest is to run your 4 chalk samples. I'm sorry, this is really blurry. See if I get this lower, if that's going to make it clear. There we go. Run your 4 chalk samples and then rinse out the plate. Because if you accidentally get chalk into these wells, it could interfere or screw up the results you get in those wells. All right. Now, another thing you notice, there's some chalk left over on my scupula. Before I move on to adding any other solids, I need to wash that off. All right. So, take it to the sink, rinse it off, dry it off, and then you can start putting in the next solid. I'm not going to go that far just because I'm only showing you guys chalk right now. All right. So, distilled water. I have a little bit of distilled water in a beaker here. I'm going to grab, here's my water. Here's my pipette with water on it. Now the instructions say to use 25 drops of the liquid, and that is totally fine. The only one I would say maybe to conserve a little bit would be the sodium hydroxide, just because we need so much of that in later labs. All right, so I'm going to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25. And honestly, it's no big deal if you accidentally get more than 25. All right. This isn't one where having exact numbers makes one bit of difference. All right. So now you could move on to the next one and put the water in there, but just in case anything happens really quickly, what I would do is I would do your stirring and your mixing right away, right? And stir for a little bit because dissolving takes time. Now, if the 2 substances dissolve together, what should happen is the water is going to go back to being nearly clear. All right. If the water does go back to nearly clear, then it probably dissolved. If it's really milky and kind of, you can tell that there's stuff in there, like that does not look like the clear water that I put in, there is a good chance that this didn't dissolve. Yeah, and actually, if I go in there and I start spinning it up again, I can see the chalk still mixing. Now, I narrowed out dissolving. Were there any signs of a chemical reaction? So that's another thing you want to look for here. Really in this lab, you're going to see either a sign of a chemical reaction to know that you have a chemical change taking place. You're going to see dissolving, or you're going to see like mixing or layering. All right. So for this one, I'm going to stick to, I didn't see a color change. Right? I mean, yeah, I mixed something that was white and clear, and now this looks kind of cloudy, but that I would expect that color change. It's not like it turned pink. All right, I don't see any bubbles forming, anything like that. So I think for now, my conclusion on this one is mixing, but I am going to record some information later, which brings me to recording your observations. So what I'm doing, this is a computer-based school, so I'm just doing it on the computer, which you can too. You can also write this down if that's easier. Then you can always upload this. But I'm going to create a table. Okay. So what I'm going to do, this table will eventually be 24 rows long. but my first observation is chalk and water. I'm going to write down my observation right away. My observation later, because the instructions do tell you to let this sit for 24 hours. You don't have the 24 hours isn't a hard stuck rule, but you do want to let it sit for several hours at least. So this is one of those things where you can do it for 24 hours and then just check it the next day. Or, you know, if you're doing this right before bed, check it in the morning. I'm just going to say observation later, and this last part we're not going to fill in today. But I highly suggest you be doing something like this as you go. Oops, actually, this is going to go here. So my observation right away, I can tell it's not dissolving. No dissolving. Looks like it just mixed. All right, so later, if anything looks different, I will make record of that. Like, you know, maybe later, actually I can even, it's hard to tell here, but I can tell right now that the chalk is starting to settle out in the bottom, which means probably later when I look at this, I'm going to call it layering. So you've got chalk on the bottom and water on top. All right, so next one is the citric acid. Where'd that go? So that one is using the dropper bottle from your kit. So you actually don't need a pipette for this. Now, I just opened mine and it is leaking. So I'm just putting that, I'm kind of collecting that in the cap so that I don't accidentally contaminate something. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm going to stop there. That kind of looks like enough liquid. Okay. And I already rinsed off and dried off my stirring rod, so I'm going to go ahead and start stirring. I'm going to say this pretty much looks like it's doing the same thing it did with water. I can still see some chalk floating around. Maybe it's dissolving. It might be going a little bit clearer. Actually, I just noticed that I accidentally went into the well next to this. So before I do the next round, I'm going to have to rinse out this plate, or I'll use a different plate. Let's see. Let's see. As I spin it around, I can still see a little bit of chunks of chalk. So I don't think it's dissolving. I'm a little less certain on this one because it did. Nah, it's not really clear. So I think, again, this is mixing, and I might see it layer again like I did with the water. But for now, I'm pretty sure it's not dissolving. Actually, I'm just going to, for now, copy and paste what I said here. Sorry. There we go. All right, next one is vegetable oil. So I have my vegetable oil pipette. So for this one, it won't exactly go clear because vegetable oil has kind of a hue to it. But it's possible that it might go back to looking like your kind of yellowish, transparent vegetable oil if dissolving happens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, that looks good. So honestly, there's usually a few extra drops in there, so I'm just stopping at 20 because I don't think I'm necessarily too far away from 25 in that case. All right, so I rinsed off my stirring rod. I just have a beaker of water sitting next to me that I put it in. And let's stir this up. All right. And if you ever get to the point where you think dissolving might happen, but it's not working out perfectly, you can always add some more of the liquid and the solvent to see if that makes it any better. Because I will say that vegetable oil, I see some chunks of salt down in the bottom, but it's kind of like I see chunks of salt and then everything looks like normal vegetable oil. So I'm wondering if that is dissolving. So I'm going to add a little more vegetable oil just to see if I can get it all to disappear. The chunks that are left are bigger ones, so it's possible that they're just too big to dissolve. BO for vegetable oil. Yeah, because it's definitely not looking like this cloudy thing like I have with the other two. The vegetable oil portion of it is still pretty normally clear for vegetable oil. You guys can almost even make that out in the video because you can tell the top two have this kind of whitish hue to them. And you can see things, and then the vegetable oil looks much clearer. Yeah, even more of the chalk particles seem to be disappearing. All right, so yeah, I am going to call this one dissolving. And I will give you a hint, chemically, that actually makes a lot of sense. So, chalk and vegetable oil. I say that is dissolving. All right, so last one is the, turn off. Sodium hydroxide. Let me clean it off. So harder to clean off vegetable oil because it doesn't exactly mix with water. Make sure it wipes this off really, really well. Now, if you're using toothpicks instead of the stirring rod, then you just toss the toothpick after each stir. All right, so I have my sodium hydroxide. I'm going to scoop this up so that you can see the well better. $12, $13, $14, $15. Okay, so that should be plenty. That way I can conserve some of this. All right, so I got no bubbles, no like crazy color change. Let's stir it up, see what happens. Let's see. Let's see. Now, I know the detail of what I'm seeing, you guys really can't, but what I'm seeing is I'm stirring it up. I can see the chalk particles just kind of floating around. But then they are immediately settling back out. And keep stirring just to make sure. Yeah. So I don't know, can you spot the layer at all? You almost can. You can kind of see how at the top of the liquid there's almost this gray layer, and then there's the white one below it. That's the chalk settling out at the bottom. So this one is immediately forming layers. I can't even really get it to mix together at all. So chalk and NaOH, or sodium hydroxide. I'm going to say immediately layering. Which means when I look back at this later, it's still going to be layers. All right, but the key is this one here and later, you know, these guys where I could tell it wasn't dissolving and it just seemed to be mixing together, I can even already tell with the chalk and water that layers formed. All right, the citric acid and chalk still kind of looks like it's just mixed. So again, you want to let this go for a few hours before you do your final observations. But between now and when we have class next time, so next Tuesday, if you're able to get this done and just record these observations, our focus for class next time is going to be a review of how to tell chemical changes from physical changes. All right. And then we'll discuss, what I'm looking for as far as your lab report. If you do a table like this, you're actually saving yourself some time for that lab report. All right. So if you have any questions, let me know. Otherwise, from here, you just move on to the next column. All right, which is the sodium chloride column, and then the same for salts. Okay, just remember, less solid is better. It'll make it easier for you to tell what's going on.